In this video you learn how to program a genetic algorithm to solve the knapsack problem. This is Kira, a little sorceress apprentice. For her birthday, Kira got a new bag that can carry magic mushrooms. She wants to surprise her parents and goes to the forest to collect magic mushrooms. Kira finds a good spot in the forest and starts collecting. When the sun sets, Kira needs to go home. She packs the mushrooms in her bag, but then she remembers something. Her bag can only carry 1300 grams. That is about 2.8 pounds. Kira needs to find a way to bring home as much as possible without breaking her bag. Kira found 16 mushrooms. She weighs each mushroom. Here are the weights in grams. She starts adding the weights in her head, and these are the mushrooms she can carry. The sum of their weights is 1228 grams. But this would not fill the bag efficiently. There is room for more. Adding mushroom 7 would overload the bag, as well as mushroom 8. Mushroom 9 would fit and brings the total up to 1249, but that still does not fill the bag efficiently. It's getting dark. What to do? Kira grabs the 7 mushrooms and puts them in the bag. The forest is no place for young wizards and Kira hurries home. She starts to think about the problem. What would happen if she would try all combinations of mushrooms? Perhaps this one? Or this one? Or this one? There are many combinations to choose from. In fact, with 16 items there are already 65,536 possibilities. And Kira cannot make a mistake. Any combination resulting in a weight over 1300 grams will rip the bag. She needs an algorithm that creates possible lists of groceries and choose what solution is best. She already knows that trying out each possibility in her head is not possible. This kind of brute force approach is even very hard for a computer when the number of possibilities grows. But there is another way to approach the problem. It is the genetic algorithm, and the approach is different from brute force. So, how does it work? There is a list of mushroom weights. A list of binary values with the same length is created. 1 means the mushroom is in the bag. 0 means it is not in the bag. This list is called a chromosome. Values in the chromosome are called genes. When the algorithm starts, the genes are initialized with a random binary value. In fact, the initialization process generates a list of chromosomes where all the genes have a random binary value. This list of chromosomes is known as a population. Each chromosome in the population results in a total weight. Now there will be a difference between each total weight and the target of 1300. This difference determines something called the fitness of a solution. The smaller the difference, the higher the fitness. The fitness can be used to sort the solutions. But before we can do that, remember the following rule. The weight cannot be over 1300 grams. This solution is not valid, so all solutions over 1300 will be set to 0. This will result in a very low fitness for that solution. So when the solutions are sorted, it will look like this. And now this is the winner. And it is really close to 1300. But the result is not perfect. To make it perfect, the genetic algorithm performs its second important task, evolution. Evolution has 3 steps: selection, crossover, and mutation. But before I explain how that works, I will create the code for everything you have seen so far. Kira starts by adding all the mushroom weights in a list. She initializes the population. And we'll start with a single round. That means that the system will not learn yet. A population of random binary values is created. She imports random and starts the algorithm. When she executes the code, nothing will happen yet except for the print statement. No errors. At this moment, there is a list of mushroom weights and a matrix of chromosomes. Kira needs to combine them to calculate the sum of weights for each chromosome. For this, she creates a class. The class defines the maximum weight and has a class initializer that takes the list of weights and a single chromosome. Kira creates a list of weights of the mushrooms that are in the bag according to this chromosome. And calculates the total weight. And if the weight is over the max weight, she sets it to 0. Kira creates a list of weighted instances. She prints the list. As you see, each chromosome in the population results in a weight. But they are not sorted yet. For this, Kira needs to implement dunder less than in the weighted class. Now she can sort the list of solutions. She executes the code again. That works. Here is the full output. As you see, the weights that come closest to 1300 grams appear on top. Solutions with a total weight over 1300 grams were changed to 0 and appear on the bottom of the list. At this point, the first step of the genetic algorithm can start: selection. Since Kira already sorted the population, the selection is easy. She will keep the 2 best solutions. Instead of printing the sorted weights, she stores the best in a new list and prints the number 1. This way she can track if the result improves once the evolution is started. Does this work? Yes, it does. Notice each time Kira executes the code, the result changes because the chromosomes were initialized randomly. Time for step 2 in the genetic algorithm: crossover. In this tutorial you will learn a strategy called one-point crossover. Look at the best 2 weights. They were the result of the chromosomes of parent 1 and parent 2. A random crossover point is chosen. The parent chromosomes are split at the crossover point. Then 2 offsprings are created. Offspring 1 gets genes up to the crossover point from parent 1 and genes after the crossover point from parent 2. And offspring 2 the inverse of that. And this process is repeated until a complete new population is created. Kira decides to also keep the 2 best parents. So for a population of 20, 18 offsprings need to be created. So how does that work in the code? The first thing Kira does is get the chromosomes from the best solution. For this, the weighted class needs to store the chromosome. Which can be used like this. The 2 best chromosomes will be copied to the next round and remain unchanged. Now the rest of the chromosomes will be created. The population count is 20, so this loop will have 9 iterations. Each iteration will create 2 offsprings. For the 1-point crossover, the split index is somewhere random in the chromosome. Kira creates an offspring with part of parent chromosome 0 and part of parent chromosome 1. And an offspring with the inverse of this. The offsprings are added to the list. And the offsprings are assigned back to the chromosomes. Let's see if this works. It does. Kira increases the rounds. Look at the best weights. They are not evolving. You just saw that after a while solutions do not improve anymore. The result was not bad, but we know we can do better. When a system does not improve over time, we say it is stuck in a local minimum. To move a population away from a local minimum, mutation is added to the offsprings. And that is the 3rd step in the genetic algorithm. When offsprings are created, every now and then one of the binary values will be reset randomly. Now, by adding new randomness to the system, most solutions will not improve, but some will, and they can get the population out of the local minimum. Watch how it works. Before adding the offsprings, Kira is going to apply some randomness to them. She creates an index to loop through the chromosomes. And every now and then mutates a gene in C1, and in C2. Let's see how that works. This is impressive. Kira executes the code a couple of times. Look at the result. That is very good. Instead of trying 65,536 possibilities, Kira was able to find a perfect fit in only 30 generations. AI is a technique that requires some getting used to, but it is exciting to see what can be done with a few lines of code. Suddenly you realize that the brain behind artificial intelligence are developers like us. But what I showed you here is just a small part of AI. If you want to build AI and neural networks from the ground up, I can show you how to do that step by step. And if you want to see how that works, click on the link in the description. There you can preview my course, Build Neural Networks with Python from Scratch. I'll see you in the next video.